Hey everyone, you know that feeling, right? That little voice in your head that says, I can make this code run faster. We've all been there. But here's the crazy part. What if I told you that giving into that urge is often the worst thing you can do? Yeah, seriously. So let's get into it and talk about the right way, the disciplined way to think about performance.
So first up, we've got to talk about something I call the optimization trap. It's super tempting, right? This idea that faster code is always better code. But, and this is a big but, it's a trap that can actually make your software a whole lot worse.
I mean, look at this quote. Jackson's rules of optimization. Rule 1, don't do it. Rule 2, for experts only, don't do it yet. That sounds completely nuts, doesn't it? Don't optimize? But this is our starting point. It perfectly nails the big idea here. Optimization is like playing with fire. It's powerful, but it's so risky that your first instinct, your default answer should always be, nope, not touching it.
All right, so let's get on the same page. What even is code tuning? Think of it as microsurgery on your code. We're not talking about a total redesign, we're talking about tiny changes. Swapping out a function call, tweaking a loop, just little nips and tucks to save a few milliseconds here or a few kilobytes there, all while making sure you don't accidentally break the whole thing.
And it's just as important to know what code tuning is not. It is not a magic bullet. It's not a band-aid for a broken leg. You know, if your whole design is a mess, or if you picked a fundamentally bad algorithm, no amount of fiddling with the little details is going to save you. It's like trying to polish a car that has no engine. You got to fix the big problems first.
Okay, so if jumping in and tuning isn't the first step, then what is? Well, the real problem, the real puzzle, isn't how do I make this code faster? It's where is my code even slow? We're on a hunt for the real culprit, the bottleneck.
You've probably heard of the 80-20 rule, or the Pareto principle. Well, it is absolutely 100% true for software. Get this, about 80% of the time your program is running, it's just hanging out in a tiny little 20% chunk of your code. And honestly, that's amazing news. Why? Because it means we don't have to optimize everything. We just have to find that small, critical part.
And these critical sections, we call them hotspots. That's the bullseye. Our entire job, our mission, is to find that tiny 5 or 10% of the code that's doing all the heavy lifting. Because trying to optimize anything else, it's a total, complete waste of your time and energy. Seriously.
So, how do you find them? Do you just, guess? No, absolutely not. Your gut feeling is almost always wrong when it comes to performance. The #1 rule is this. You don't guess, you measure. You have to use a tool called a profiler. It's like an MRI for your code. It gives you cold, hard data and shows you exactly where the time is going.
Okay, so let's say you did it. You measured, you found a real bottleneck. Your first instinct is probably to just dive right in and start changing code, right? Whoa, hold on. Before you write a single line, we need a map. We need a mental model that shows us where the biggest performance gains are actually hiding. And that map is...
Just take a look at this. It lays it all out. The stuff at the bottom of the pyramid, the big, wide base, that's where you get the most bang for your buck. And the stuff at the very tippy top, that has the least impact. And here's the secret that blows people's minds. The biggest performance wins are not at the code tuning level, not even close.
Let's actually walk through the layers, from most impact to least. You ready for the biggest win of all? Just changing the requirements. Seriously, convincing someone that you don't even need that super slow feature in the first place. That's a massive win. Next down is the big picture stuff, your overall program design, picking a fundamentally faster algorithm. Then you've got choosing the right data structures for the job. And then, way up at the top, the last and smallest piece, that's our friend, code tuning.
All right, but what if you've done all that? You've climbed the pyramid from the bottom up. You've measured. You've found a genuine, bona fide hotspot. And you've decided, okay, I have to tune this piece of code. Well, you still don't just go in there and start hacking away. There's a process, a strict, safe, disciplined loop you need to follow.
Think of this loop as your safety harness. Step 1, save your working code. Make a backup. Seriously. Step 2, use your profiler to find one hotspot, just one. Step 3, make one single tuning change. Not 2, not 3, 1. Step 4, measure it again. Did it get better? Awesome. Step 5, if it didn't get better, or if it got worse, you throw that change away, revert to your baseline. You have to be ruthless about this, because guess what? Most of the time, your clever change will do nothing or even make things slower.
Here's a super classic example you see all the time, especially in Java. Building up a string inside a loop using the little plus sign, it's famously bad for performance. Why? Because every time you do that, you're creating a brand new string object in memory. It's super wasteful.
The tuned way is to use something called a string builder. But, and you knew there was a but, right? This is the key takeaway. You only make this change if your profiler points a big flashing arrow at this exact loop and says, this is your problem. If it's not a hotspot, you're just making the code harder to read for absolutely zero gain.
Okay, let's wrap all this up. I want to give you a simple 3-step mantra, something you can literally repeat to yourself every single time you start coding. If you follow this, you will never fall into that optimization trap again.
Step 1. Make it work. That's it. Just write clean, simple, obvious code that does the job correctly. Don't even let the word performance enter your brain, because a fast program that's wrong is worthless.
Step 2, make it right. This is different from making it work. This is about elegance. Is it readable? Is it easy for the next person to understand and maintain? This is where you focus on good design. And funny enough, good, clean design often ends up being performant all by itself.
And finally, step 3. Then, and only then, do you make it fast. And you only do that if you have proof, actual data from a profiler, that you even have a performance problem to begin with. Then you use that safe loop we talked about to fix it.
So I want to leave you with one final question. The next time you feel that itch, that temptation to make some clever little optimization, just stop and ask yourself, is this change going to make my code better based on real data, or am I just making it more complicated for no good reason? Remember, the goal isn't just fast code, it's good code. Thanks for tuning in.